Next up is Greg Appelbaum. Greg is a professor of psychiatry at UC San Diego. He's part of the Human Performance Alliance as part of a moonshot project, which is on the multi-scale athlete.
Thank you for the invitation. It's great to be here. I'm a cognitive neuroscientist, so I look at the human performance through the lens of brain and behavior, and particularly vision, and that's what I'm going to be talking about today. I'd like to start with these slow-mo videos of iconic athletes, and I want you to pay attention to their eyes. You can see in each case they're devoted to paying attention to the task at hand, according to the kind of saying, you keep your eye on the ball. So we can think of vision as a central aspect of sports performance. It's the signal that leads the body, and it's an area that we've been researching in my lab for the last decade. Fortunately, over the past couple of years, there's really been a proliferation of tools to measure vision in athletes digitally. This includes vision screening, mobile eye tracking, and mobile EEG. So we can monitor behavior and brain digitally of athletes. And to borrow a slide from Carl from a moment ago, we would say that these are important factors to include in the building of a digital athlete. And moreover, when we understand the important role that vision plays in performance, we could also tailor digital techniques to improve performance. So training using digital aspects that feature what we know about the vision of digital athletes, or what we know digitally about vision in athletes. So I'm going to talk now about some of our studies we've done over the past couple of years that have been linking vision in athletes to performance, and then training of vision to improve performance. So let me introduce you to this device. This is the Sensory Station. It was originally developed by Nike as part of the Spark Sensory Performance program. It's a digital kiosk that has a high-resolution monitor and a touchscreen display. And it has 10 tasks that measure vision and sensory motor control. Some of them are what you might experience in an optometrist office, things like visual acuity, contrast sensitivity, depth perception. Really, what is your sensitivity to the visual stimuli you're looking at? Some of them are more cognitive in nature, things like multiple object tracking and perception span, your ability to kind of make sense of the world cognitively. And some of them are motor control based, things like eye-hand coordination and go, no-go. Importantly, when an athlete performs these, they put in their sport of performance and their level of performance. So if they're an NFL quarterback, they get back a performance profile that compares them to NFL quarterbacks. And if they're a girls' soccer high school goalie, that's who they get compared to in their performance profile. So it gives a sense of what your strengths and weaknesses are and areas of opportunity to improve. So we did a lot of research with this in our lab, and I'm not going to have time to talk about all the individual studies, but things got really exciting when we created a data use agreement with Nike, and we got their database. So we then had access to thousands of athletes who performed this battery of assessments, including nearly 400 professional athletes. So this was kind of a gold mine for a cognitive scientist trying to make sense of vision. The first thing we really wanted to do was look at cross-sectional differences. Is there something about the experience of the athletes that leads to different vision, different kind of profiles in their abilities? And in this slide here, what we're showing is that athletes who participate in interceptive sports, where the goals are to intercept a fast-moving ball like tennis or baseball or softball, had different profiles of visual abilities than athletes who played strategic sports, where the goal is to track teammates and opponents, things like soccer and hockey. We also looked kind of more acutely at differences in a sample of the professional baseball players to compare pitchers and hitters. They're similar in their experiences and the practice they've done, but they have different demands on them in terms of their sport given their position. And lo and behold, we find differences in their abilities. Hitters have better sensitivity. They have lower thresholds and can pick up visual information more quickly and more easily. So that's great. Cross-sectional differences are important. We need to understand the profile of vision in athletes in order to include this in a digital athlete model. But what we really want to know is, does this predict their performance on the field? Can we measure baseline before they perform and determine if these abilities predict their ability to perform? And so we had the opportunity to do this in that sample of professional baseball players. We performed Bayesian hierarchical modeling, and we compared a model that just included their base position and age to a model that include these evaluations. And we use this to predict their game statistics from professional baseball games the next season. What we found was that the model that included the vision assessments outperformed the model that didn't, and particularly for different statistics that map on to the ability to make correct decisions at the plate. Things like on-base percentage, walk rate, strikeout rate, but not things like slugging, hitting for power. So vision is important for making contact, but not making powerful contact. We took this to the next level in a collaboration with the New York Mets, where we added in an eye tracking system that gives a sense of functional vision, developed by Right Eye, and autorefraction, so kind of basic optometric evaluations collected in the preseason on the athletes. And then we had access to their plate discipline metrics from the next season. So this is really acute information about are they making the right decision at the plate and swinging at pitches that they should. And what we found was that athletes who had better smooth pursuit and faster ocular motor times made better decisions at the plate. They were more discerning. So the notion is that they have better access to the information that they're seeing and can make better decisions when we control for all these other factors in the models. So there's some evidence that vision is important for sports. It's predictive of sports. The next question is, can we actually train vision and move the needle on sports performance? And so we did interventional trials to test this. I'm going to talk about one of them that we did with the Duke and Indiana baseball teams. This was a pre-registered placebo-controlled trial. So it's really kind of unique and rare to get access to athletes and actually have a placebo group, right? Oftentimes athletes and coaches, they think if it works, we're going to do it. And oftentimes it's hard to get a placebo in. And we had really willing partners at Duke and Indiana, and we were able to do this study. What we did is we had 20 varsity players, 10 from each school, position players. So these are all batters. We're trying to train visual abilities in batters based upon what we've learned about visual abilities in batters. And they completed 10 weeks of circuit training, and half the players were randomized into a program that we thought would improve vision. We called it the dynamic vision training group, and half were randomized into training with a placebo. And so the dynamic vision group, kind of a central tool that we use in there are these strobe glasses. They were also originally developed by Nike in their Sensory Performance program. And these are digital glasses with liquid crystal lenses that shutter open and closed. And so the idea is that you practice throwing, catching, hitting, strength and agility drills under these impoverished visual conditions. So it's like resistance training, like running at altitude where the air is thin. This is training vision where vision is thin. And then when you take them off, you reap the benefit of having practiced under these harder conditions. So we had them practice hitting, throwing, catching. We also had them do anticipatory timing drills on a light rail and other dynamic drills on a tablet. And we compared this to a placebo group that also did challenging drills, but they didn't have a vision manipulation component. So they did things like binocular exercises monocularly. What did we find? Well, from pre to post training, we found that the group that trained with the dynamic vision program improved in their batting performance. They were able to hit the ball farther and at a higher angle relative to the placebo group. You can see that in those two plots there. So we were able to start to move the needle in an intervention where we could target vision, and it leads to improvement in batting performance, sports performance. So all of those are studies that we've done, we're excited about, they're all published, you can read all about them. Right now we've engaged in a new line of research at UCSD with the baseball and softball teams using virtual reality training. And so in particular we're using this system called Win Reality, which is a VR-based system that is in an Oculus headset that combines the video capture of pitchers to create an avatar that gets spliced together with tracking of their pitches. So it creates a really high resolution, high fidelity training scenario that we could then do training exercises in. Different drills like pitch recognition, strike zone recognition, and these are done with an occlusion training program. So we're actually manipulating the visual stimulus where if they get the right decision on one at bat, then on the next pitch, the flight of the ball will break off earlier and earlier. So it's encouraging the person to make decisions quickly and manipulating their vision to do it. And so we're engaged in this right now. We're really interested in, does this digital simulation actually capture game performance? And can, again, we move the needle on their game performance by training under these scenarios? So in conclusion, we see that there's promising evidence that vision is specialized in expert athletes, that it's predictive of on-field success, and that we can improve sport performance through training of vision. So with this evidence, we would say that these are important elements to include in the building of a digital athlete. Thank you very much. Thank you.